Yeah. So you can use that piece of paper again for your notes, just like the last time you did graphs. Graphs are kind of an important thing. And if you want to follow along in the book, sometimes that helps too. If you want to open up to page 383. 383. You can kind of, because we'll be going over, they gave you some definitions there, and we're talking about that line graph. You can see an example on the bottom of the page where they have a line graph. And just some of the words we use when we talk about line graphs are these two lines right here. What are those two lines called? Well, the one that goes up and down, the vertical one, we call, you see those of you looking in the book, this is the, what we call the y-axis. Why? Because I don't know. Everything in math is either x or y, it seems like. It's the y-axis and it is the vertical axis. This one here that goes this way, guess what it is?
Horizontal.
Oh, look at that. Or what letter?
X.
Yes. Horizontal or the x axis. Okay. And they're specifically talking about today a broken line graph. If you look at the one that they have down there, give you a chance to write that down. Get that down there. And they give you this whole monthly thing here where they have, wait, let me change the colors a little bit here. On the horizontal axis, we have what? The months of the year, correct? On that one graph they give you there. Look at how nice and thin those lines are. And then on the vertical axis would be what? What's the graph about on the bottom there? Work with me here. Temperature, yes? Yes, Mr. Hahn, that's exactly right.
Yes.
Word for word, nice job. Why do you suppose, by the way, this is a graph of what? The average Boston temperatures. Average Boston temps. Why do you suppose they use this type of graph as opposed to a pictograph or a circle graph or something here? What is this, 10, 20, 30? Because they give you this 10, 20, 30. This one is what? January, February, March, April, May, June, July, August, September, October. Look at that. I didn't even plan on it and I nailed that. All 12 months. It is kind of something special, isn't it? Why do you suppose they use this? What does this show you? If you take these things and actually connect them. Why would you use that line graph? Why would we use line graphs? Anybody? Look at it, it keeps going up and up and up and up. When does it start going down? Peaks out in what? January and goes down in August? I don't even know if this is right, I'm just kind of pretending like I know what's going on. You use line graphs when you want to show, anybody? Not always temperature, but when you want to show change. Because you can quickly look at this and say, oh look, the temperature keeps going up and up and up and up and up and up until you get to July, and then what starts happening? It drops. And then you get to where we've been here in December, and you get down here somewhere, way below zero, because it got crazy cold on us. Yeah. We can flip the page here. You can turn, they actually connected the dots for you on the other page there. Take a look at page 384. You might as well, because I'm going to ask you to answer this question. You don't have to draw that graph, by the way.
What?
I was just showing you. If you did, it's okay. Don't erase it. You've got plenty of graph paper. We're not going to use all those graph papers. No work is ever wasted, 5th grade, whether you need it or not. Ask the farmer, right? No work is ever wasted. It's good for your penmanship. It's good for your work ethics. Take a look at problem number 1 on page 384. It is 84, isn't it?
Oh, yeah.
Question number 1, and look at the book, because this comes out of the book. Look at the book. In what month was the highest average temperature, and what was that temperature? What month was the highest? See, and because it's a broken line graph, you can see where the highest one is very easy because it's the peak up there. And Ellie Stewart says,
The month of July and the
Here's where-
temperature is about 75.
oh, you know what? Guess what my book says? River, what's my book say? Nope.
72.
Carolina? Oh. And again, because it says about, you're actually not wrong, River. You're not wrong. I'm gonna leave it. I just conflict acting. John, it is.
74.
They say 74. I'm just that's. Number 2 says what range of the average temperature shown, or what is the range of the average temperature shown there? Do we talk about range?
Yes.
And range is the difference between the biggest and the smallest. Let's see if anybody can get this right on the nose from what the book says. I may have to do some calculating there. What was the highest temperature? What's the smallest temperature? And then subtract them. What do you get? You can smell something burning. That's your brain. Yeah, something's cooking.
What's cooking now? The rock is cooking.
Let's see how many people get what the, by the way, the book says about again. Let's see if you get the same about that the book gets. Acceptable tolerances. Kevin?
44.
Yep, they get 44, because the lowest temperature was 30. That was this one here. And the highest one, we already said, the book said, was about 74. So if you subtract those, it's about 44 degrees. I wonder if ours is the same. Do you think our weather would be, our range would be higher or lower than Boston?
Higher right now, because we're like.
No, you can't change it now.
Yeah,
What would you guess if you had to say, John Lick, in July, which is probably our hottest month, what would you say our average temperature is? No, you don't have to look in the book because it's not in there. I'm just asking you. In July, when you guys are out of school and it gets to be hot and you have to spend all your time indoors because heaven forbid you go out when the temperature is above 70 degrees, what would you guess? What would you guess the average temperature around Illinois would be? What would be your guess? Somebody have a guess there? Ellie Norquist, what would be your guess? 75? I think that's pretty low myself.
Yeah.
That would be, yeah, that would be, everybody'd want to be outside in that. I would guess low. Ethan?
Maybe 80.
I would say you're probably pretty close there. You know, you might say, but it gets really hot in July, but it's usually not that hot every day, so it's an average when you start thinking there. I would guess 80, 81 degrees, maybe 82. Now, why would our temperature, because Boston is probably close to the same line we are, it might be a little higher. Why would Boston's temperature only be 74 and ours be almost 10 degrees hotter? Any idea? We'll drop this into some, scientific kind of stuff here. Kate, why?
We're closer to the equator.
Yeah, a little bit, but I don't think that accounts for 10 degrees, actually. I think there's a bigger factor. A bigger factor than that. Kevin? You have to know your geography about where Boston is and where we are. Boston. John says.
It's kind of like because Appalachian Mountains and Rocky Mountains, it's because of the lake effect too, or ocean effect, I guess.
That would be it. I don't think the mountain ranges have anything to do with it. It's
Well,
way,
it has to be-
Boston is way on the coast, which means it's next to the ocean. And because water doesn't change temperatures, it's like when they talk about, when you go to Chicago, it's always either a little warmer than we are, or a little colder because it's right on Lake Michigan. Well, think of Boston's not on Lake Michigan, it's on the ocean. And the ocean water doesn't change temperatures that easily, so it's always going to be either cooler in the summer or hotter in the winter, warmer in the winter because it's right next to there and it just, the water cools stuff off or heats it up. So I would guess, what was their lowest temperature? Yeah, what do you think our temperature is in December?
Like
I think in December, what do you think, Mrs. Price? It's probably 30. It's probably 27 or 28 or something. I don't think that's average. This year we had like a really cold spell that we rarely have. But if you did last December, it barely got 40s, below 38 degrees. So, and again, it's the same reason Boston's temperature actually will be higher than ours is because they're by the water, and the water keeps it warmer in the winter. And then now question number 3. From March through June, the average temperature increases about how many degrees per month? From March through June, how much does the temperature go up pretty much every month? And you can see I have it here. It kind of stayed in a nice straight line where it goes up the same amount every month. How many degrees? Look.
9.
No, I think you're close. It might actually says 10, but I can see how you get 9 because those blue dots are a little bit less than those 10. I agree. It says about 10 degrees per month. Now, look at number 4. Guess what you're going to do? It says every 2 months, Liz weighs Jake her Labrador Retriever. How many of you have a Labrador Retriever? Puppy one? Is it right now a puppy?
Yeah.
How old? I wouldn't expect you to know too much about it. You are going to make a broken line graph to show that. You looking at that little table there? But before you start, let's talk about a few things. Before you start, let's talk about a few things. It gives you, here's your little table, right? We've got birth, and then we've got, what do we separate it into? Every, how many months?
Every 2 months.
2 months, 4 months, 6 months, 8 months, 10 months. Is there 12 months?
Yeah.
There is 12 months. And then what is the weight? Looks like the weight goes from 0.5 to 6 to what? 12, 17, 21, 12, 17, 21, and wow, 24, 27. Where did I miss one? How come I'm not right? Oh, was birth 0.5? Sorry. 0.5, 6, 12, 17, 21. What was that one next one?
24.
24.
No.
If, wait.
No.
What did I
10
do
months
wrong
is
now?
24, and 12 months is 25.
24, 27. Alright, if you are making, you have the graph there, so you're going to use this piece of paper. Doesn't matter what are our labels going to be and where are we going to put them? First of all, we need to label the whole graph. So what's the label of the graph? What is this whole thing about? Jake's weight. That's a good one. Let's do it. Let's do Jake the Labrador. The lab. In quotation marks. Jake the lab. Wait. Jake's the lab. Wait. And then you need to decide, here's the tough part about making graphs. Okay? What is going to be what? What 2 things are we comparing? We are comparing time to weight. Is the vertical axis going to be time or weight, and is the horizontal axis going to be time or weight? Which one is most sensible? When we did the last graph, which one was time, which one was temperature? Which one makes more sense? Because when you do your, when you do this up and down thing, you want these all to be equal. Which one are you going to put where? The one that you want to see change in, you're going to put, who's got it, Connor? This is going to be horizontal or vertical. This is horizontal, this is vertical. weight is going to be vertical what? Yes, this is going to be the weight. W-E-I-G-H-T. If this is the weight, then what's the horizontal one going to be? Pretty easy to distinguish. It's going to be and we can label the horizontal one right away because we know what it's going to be. What do we have? It is these numbers up here. Here is birth, which is 0 months old. And you're going to label this as 2 months, 4 months, 6 months, 8 months, 10 months, and 12 months. Everybody a label in that thing there? Do we have enough little dots? Now here comes the most difficult thing. What do each one of these lines stand for? Because you have to pick and make it yourself. And the thing you have to remember is, God bless you, God bless you, God bless you. You have to remember all of this data has to be able to fit in there. So you know you got to go at least up to 27, and the bottom has to be, you know, whatever, 0 or 0.5. So how many lines do you have, and what would be the logical, what would each line stand for? And it has to be equal. You can't say this is 0, this is 2, and then this is 10. You have to count by whatever numbers. What would get you the best way there? We really need to go from 0 to 30. So if you take, how many lines are you given? How many lines do you have? Not mine. 8. So if you're going up to 30 and you have 8 lines, and you probably don't want to go, you can't do fractions, you got to do whole numbers. What would make sense? If you did every line as 1, guess what you'd end up with? You could only get up to 6 pounds. So right away you're off the graph. If you did every line as 2 pounds, you're only going to get 2, 4, 6, 8, 10, 12, not big enough. If every line was 3 pounds, you get 3, 6, 9, 12, 15, 18. If you did every one was 5, let's see, would that help us out? 0, 5, 10, 15, 20, 30. That's what I do. I think 5 would be a good one. So go ahead, label your horizontal axes as that, and then plot your dots and connect your lines and see if yours looks like the one that the book has. How would you do 0.5, by the way? Again, graphing is not always exactly exact. 0.5, you just have to put a little bit above. Remember how we got confused on 73, 74, 75 on that one? Well, that's kind of the same thing you're going to have to do. If it doesn't fall exactly on the line, you have to put a pretty good guess or a pretty good estimate where that one will go. Pretty good guess or a pretty good estimate where that one will go. I'll give you a second to finish that graph, and then we'll take a quick look at it. We're not coloring it in, they're not bar graphs, we're making a broken line graphs. Fill in the information. Fill in the info and make a broken line graph for me, please. So at birth, you put a dot at 0.5. At 2 months, you put a dot at 6. And remember here, children, this is something where people get confused too on this. When you're plotting points, you never put them in the middle of things. For example, at 2 months, it's 6. So 2, you go up and your dot's going to be on this line somewhere. 2 is 6 would be right about there somewhere. 4 being 12, there's 5, 10, 15, 12 is good. You don't put dots, never will there be dots out in the middle of this where it's not touching at least one line somewhere. And they're always going to be on these lines. No, yours are right. Yours are right. Sam upset because we didn't know that. Amanda Vanders?
Olivia Chloe. Yeah, she's there. Chloe is in the
So finish that up and let's see what yours look like. Van, you can just kind of jump in here. We're not doing anything for a share. Unlike most days. So take a look up here. Hopefully your graph looks pretty close to that. Again, there's always a little bit of wiggle room. The book asks you, based on what you're seeing here, what do you think the dog's weight will be at 14 months? And again, you don't know for sure, but it's a prediction. If this line keeps kind of growing up there, what would you think? We've got a guesstimate there. What would you think the dog would weigh, Robbie?
around 28 pounds.
Yeah, maybe 28, maybe 29. The thing you have to kind of remember is that our dog's going to keep growing forever. No, they stop. I don't know. Different dogs stop at different ages. I don't know a lab. It probably keeps growing until it's a year and a half old. I don't know. Is that how long will it? They get a lot bigger even after a year, I think. So it's going to stop. Take a look then. Page 385. When you look at the graph on the top of page 385, what's the first thing you should look at? You should look at what is that graph about? What is that graph telling me? And it is about what, Brady?
It's about the value of his stock.
Yes, Mr. Escobar invests in stock. He has constructed a line graph to show the value of his stocks at the beginning of each year. So let's answer those questions there. Maybe if you're lucky, we won't have any homework. Number 7. How much were Mr. Escobar's stocks worth at the beginning of 2001? The beginning of. Notice how time is always the horizontal line. In 2001, the stock, Sam, looks to be about worth $10,000. Shouldn't stocks keep going up? What happened in the year 1999 to 2000? Yeah, I wonder why they dropped. Anything could happen. New president was elected. Country hit a recession. Yeah, Donald Trump wasn't there then. The second part of question number 7, how much were the stocks worth at the beginning of 2003? 2001, we said they were worth 10,000, but at 2003, they were worth, Leah? My book says exactly about 9,000, which is halfway between them. Number 8, at the beginning of which year were his stocks worth the most? When were his stocks, Brendan, worth the most?
1999.
1999. You weren't even born in 1999. You guys were born in 2001. That was a great year. Number 9. During which year did his stocks increase in value the most? Now remember, what year did they go up the most? Now you kind of got to look at that line. What line has the steepest amount of going up? Which year? Jonah?
From 1998 to 1999.
Boy, I think there's a year that it goes up a little faster than that. From 98 to 99, they went up $2,000. Yeah, 97 to 98, it looks like it went from 7,000 to 12,000. That's $5,000. That's a pretty good chunk of change. Number 10. During which year did the value of the stocks decrease? Go down the most. Going down the most, Kendall, was 99 to 2,000. And how much did the stock go down? A little bit of calculating here. Northwest? $4,000. Number 11. Estimate the overall change in value of the stocks from the beginning of 96 to 2006. That's 96, the first one, to the last one. How much did it go up? How much did it go up? Going once, going twice. It went up. Ellie? $5,000. Okay, here's what I do want you to do. This won't take you too long. That activity where it says, I want you to make that one line graph down there on the bottom in the blue box. It won't take you probably about 6 or 7 minutes. Remember though, the hardest part, take a look up here so I can get you started on that. You know time goes down here, so this is going to be days. The hardest part is you figuring what do each of your lines going across stand for. And you won't know the highest point till you figure out what number 7 is. By the way, what are you doing to each number to get the other number? If you go from 1 to 30, what are you adding? 30. So what will number 7 be? Have we added that far yet?
210.
It will be 210. So it's probably going to be in your best interest to do 30, 60, 90. Do you have enough lines to do that? You have 7. Who doesn't have a piece of graph that's not used yet? Who needs another piece of graph paper? If you need a second one here, if you started writing all those classes, you need another one. There might be and that will be your 1 and only assignment for tomorrow. Anybody else need one? Kate, you need one? There might be one sitting on that counter back there.
It says make a line graph.
If you need a little help, come talk to me. Or